In our last student video, we covered different knots that we were going to use for primitive fire making. And so we went with the clove hitch, and we talked about how you could put half hitches in if it was going to go on a hand drill. We also talked about a double figure eight on a bot for the thumb loops. And we talked about the lark's head. Lark's head will be the only one we're not going to use in this video, but we will use it for future methods of fire making. So in your introduction, talk about how you have a connection between learning styles and tying knots, and how that's going to be used for this activity of making a thumb loop hand drill. So make that connection with the prior subject, being learning styles and knot tying, and how that's going to be used in conjunction with types of knowledge and actually applied to a form of primitive fire making. So in the next segment of your video, talk about spindle selection and the types of knowledge that was needed to select the appropriate spindle for a hand drill. So talk about the diameter needed, being about pinky finger size, the length that would be appropriate for a thumb loop hand drill, and even the materials needed. So here we're using yucca or soltol, so this one being soltol, this one being yucca, and why those are good, and how that would be linked to types of knowledge. So declarative knowledge. What declarative knowledge, factual information would be needed to select the appropriate spindle? Once you have the spindle selected, talk about the types of knowledge needed not only to select the type of cordage, like how thick that cordage is, because the thickness of the cordage will affect your ability to get rotation on the spindle, but also on the length, like what length is appropriate. And that's going to vary based on the length that you chose for your spindle. So let's go through real quick and talk about tying that clove hitch again. So you already know how to do this because we did this on the learning styles. But I'm going to take a bight in the rope, go from left to right, take another bight in the rope, go from left to right, and I'm going to put the one in my right hand behind the one in the left. So I took the loop in the right hand behind the loop in the left. That's going to give me my initial clove hitch. So you're going to find this thinner diameter rope is way better to use. Now you'll notice that's way too long. That would put my hands down there near the fireboard, and I don't want that. But I also want to be able to put in additional half hitches. So you notice I made a little loop here behind the spindle. Same skills that we had on learning style when it came to tying knots. I'm going to put a half hitch in below, and I may, so I'm just looking at the length here, I'm going to put in another one. So I'm going to put two below, and then I'm going to put two above. So you'll notice I already have the double figure eight tied. So if you don't know what I'm doing here, I'm taking a loop, placing it behind the spindle, and then I'm bringing the end of that rope back through the top side. But you'll notice I've already got the double figure eight with a bight tied in. So now I'm going to measure and see if the length is just about right. That's actually really good, but you'll notice the one on the right hand side is a little bit lower. So with this thin rope, that tells me I can probably put in another half hitch up here without throwing off. And it's fine if they're not perfectly connected or perfectly equal. And that put me right where I wanted to be. All right, so I'm really close. Those are almost equal, so that when I go back and forth here with my hands, my thumbs are fairly equal in length, and it's okay if they're a little bit offset. So now let's talk about that figure eight with a bite. Since we already have those fairly equal in length, I'm going to keep that same loop where it's at, but let's talk about tying that again. So often when selecting cordage, I'll go ahead and cut what I need so that I know it's a little bit longer, because I know I can always adjust these loops, and I tie those in first. So now I know I want my loop right around there, but let's go over how to tie that figure eight with a butt. So I'm going to go over just like I did in the other video, the one with learning styles, when we were initially tying that knot. So what I mean by going over is I took those two strands, I put a bight in the rope, and I went over. So this is going over those first two initial strands. Then I'm going under. Now I don't want to go back through here or I'll just get an overhand knot. I need to go back through the top side of the knot and then cinch that down. But I want to show you what I've done. Let's just place it down here so that you can see it real time. So I put a bight in the rope, I went over. Now I'm going to go under, right? So I went under those two strands. I'm going to go back through the top side. And then I'm going to cinch that down and dress that knot. Now these knots, because it is a different type of cordage, will cinch down way better than that cotton. The only reason I was using cotton in the other video and that you see me using it on other skills is because I can use it to make char cloth. But this diameter will be ideal for getting the rotations that I need on that spindle. The only problem is they are so thin that if I start putting too much downward pressure, they can kind of cut off circulation. So now these are offset when I retied that. So I'm going to retie this one, but I won't make you watch the video. So I'm going to bring this piece of cordage up here and make it equal. Once you have your thumb loops fairly equal in length, in that same video, talk about the types of knowledge that was needed to tie not only the clove hitch and the half hitches, but the double figure eight on a bight. What types of knowledge were most important? Obviously the procedural knowledge to tie the knot itself, it's important, because you could tie that knot with very little factual information. You could use just the muscle memory of tying the knot and get it complete. But factual information helps. That declarative knowledge is also important because you kind of need to know why you're doing that type of knot. How is it used, which would be conditional. That's also important, that explicit knowledge, that conditional knowledge of when do we use a clove hitch? When do we use a double figure eight on a bight? Why are we using a double figure eight on a bight? Because it's easy to untie once a load's been placed on it, so we can reuse that cordage. And a clove hitch is also easy to adjust and retie because we may need to move this up and down our spindle. It may shake loose, so we can easily cinch it back down. We can put more half hitches in to shorten or lengthen the cordage. So declarative knowledge is important. Conditional knowledge is also a form of explicit knowledge. And procedural knowledge, which is on the implicit side, is extremely important. We need to know the process. And you can link this to other concepts, which is conceptual knowledge is a form of explicit knowledge as well. And linking knot tying to other concepts, meaning this figure eight on a bight, if I had a bunch of people in a climbing class, now I wouldn't want my loop that large, instead of having them, if it was a beginner class, tie in with a figure 8 follow through, I would do a figure 8 on a bite and clip them in with a carabiner so I could just get them on the wall, get them introduced for climbing. Now, a clove hitch, you would not want to use a clove hitch for something where somebody's life would depend on it because it could shake loose. Now, it's okay for shelter building and tying pieces of wood together, but I wouldn't want to use a clove hitch, even a clove hitch with a bunch of half hitches in climbing, because of the risk of it untying. I would not want my life to depend on that knot. But a figure 8 on a bite, double figure 8 on a bite, or a figure 8 follow through, I trust that. And then if I fall with all my body weight on that, I know I can get that figure 8 undone. So that's conceptual knowledge. So let's talk about types of knowledge and what's needed for your fireboard, or at least fireboard selection. You're going to need to know factual information like how thick should that be, and ideally about 1/4 of an inch to 1/2 of an inch would be ideal for a hand drill, so either a thumb loop hand drill or a gas pedal hand drill. But even when making the actual fireboard itself, we also need not just procedural knowledge on how to make it, but also the facts that will go along with it. So we need to know the thickness, we need to know how deep that divot needs to go, how wide the notch needs to be, and ideally that one would be too wide. Could we get it to work? Maybe. But if it's too wide, what can happen is this spindle, as it rotates, can blow out the front part of that, meaning it'll jump into that area and push all your dust away. So that's not so great. But for thickness, it's about 1/4 of an inch, between 1/4 of an inch and 1/8 of an inch thick, so it would be okay to use. This one is way too deep now, but it was actually one that worked out. So I would carve that down with my knife so that I wouldn't have as much friction on the outside of the spindle itself. So it'd be easier for me to rotate that with my hands. But for thickness, that one is actually somewhere between 1/2 of an inch and maybe 1/4 of an inch. It's somewhere right in between those two, and that would be ideal to start my rotations on a fireboard that thick. If it's too thick, it's going to take forever for this part of the spindle to touch the dust that collects in the notch. Now this notch is a little bit better. It's a little narrow, so if I notice that the dust is just pouring out of here and it starts to kind of snake out of that notch, I know it's too narrow. So I would cut it a little bit wider. This one's real close, and you can see there's been a coal in there. That one would be ideal because most of your dust is going to stay within there, and that's going to give you more time and more heat on that dust to take it to flame. So if I started this one brand new on a board this thick, that's almost 3/4 of an inch. It's somewhere between 3/4 and 1/2 an inch thick. That's way too thick. I would want something closer to 1/2 inch or 1/4 of an inch to start off with. That way I don't burn through it too fast. This one's almost too thin. Could I get it to work? Possibly, but I'll probably burn through it too fast, and I'll probably end up going into that notch too soon and blowing out that notch with the spindle. So there we have not only the procedural knowledge on how this is going to work, the process on how these are going to go together, but really here we need that declarative knowledge. We need that factual information. We also need to know that conditional information on when to use certain fireboards, like how thick they need to be, factual, like when they can be used and with what combinations of spindles. But I would say declarative knowledge here is extremely important when you're selecting a fireboard, and how thick it is, how deep to put your divot, and how wide the notch should be to collect the dust. So once we have the spindle selected, we have the thumb loops on, and we have the divot set so that we can start working towards an ember, What types of knowledge are most important here? So really, when it comes to ember creation, we've already used the factual information, but when it comes to ember creation, it's going to be the procedural knowledge, right? The process, putting this all together. As long as we use declarative knowledge correctly to select the proper fireboard with the proper thickness, proper notch width, and depth of the actual divot, then we should be good. Now for your class, this is all going to be made for you. It may even be pre-burned in, so if y'all want to go give this an attempt, I'll try to make y'all several notches for your fireboard so y'all can have multiple attempts. But here, when it comes to actually creating the ember, procedural knowledge is going to be more important than anything for your application. You're going to have to kind of know how all these processes go together and actually use your kinesthetic skills to make an ember. So process is going to be most important. And then once you put this skill all together, have a conclusion. What types of knowledge, after it's all said and done, were most important for this skill? How did procedural knowledge fit in? How did declarative knowledge fit in? Conditional knowledge, when to use this skill? And also talk about conceptual knowledge, linking it to other concepts. Of those, in order of importance, which ones did your group find were most important?